Racepoint Energy came to be when the CEO of both our companies built a new house. He wanted to have energy independence because on Cape Cod, it's not uncommon to lose power. He built his house with, I think, 35 kilowatts of solar. What he didn't realize at the time is that when you install solar on your house, primarily that solar is feeding the grid, not so much feeding your own house. Of course, it works out that way when the grid is available, but when the grid is not, you lose it, and you don't have the ability to even use it at all. So what he wanted to do is he wanted to solve the problem, develop a way for energy independence, and then market it as a company and allow it to be accessible to all of us. Now, the way that we ended up having to do that was by starting with monitoring and measuring the energy that we use. So what we first developed was two systems that we use to do that measurement. The first is our companion breaker module, and it has 2 channels of measurement. This is good for up to 30 amps. And then for 30 amps and above, we use our current transformer-based energy monitor. And that will go all the way up to hundreds of amps. We are able to do the measurement, and to do the display and the user interface of that measurement, we rely on our partner, Savant Systems, to come up with a magical user interface.
Thanks, Will. So, because the energy monitoring is on the system, Savant used to have an interface for this years ago, and what we learned is that we really needed to update that and adapt how we provided information to the user. So what we did is we brought all that information into the Pro app. We made it scalable both to the iPhone and the iPad dynamically. And what we're able to do, the customer can come right here. This is a dashboard that allows the customer quickly to see their live usage. If we had production and battery level, we'd see that right here on this level. The user can dive in and get more detail on what individual circuits are using power right now, as well as we can do different summary views. I can get an idea of how much power I'm using over a week, a month, or a year, and really see what items in their home are using the most power.
Thanks, Tony. So now that we know where the power is going, we can make much better decisions about how to use it. Now, if you are familiar with generator systems or other alternative means of powering your house, you're probably familiar with a critical load panel. Typically, when a critical load panel is installed, you have to make a decision at one point in time what loads you've decided are critical. And to change those, you require an electrician, you require essentially a rewire. What we've elected to do is we can put all of your loads for the entire home into our dynamic critical load panel. Every one of these modules has 2 channels of control in addition to monitoring. So we can change your critical load panel based on season, based on time of day, and even now that we know more about monitoring and what you're actually using, we can be more aggressive about better utilizing that power that you may have available. There's one anecdote that I like to give. A dealer came up to us and he lives in Miami. He had a 2-week-long power outage. He had a generator, so normally it would be fine, except he didn't put his pool pumps on his critical load panel. And that's not a typical thing that you would do. What ended up happening though is he built a lot of algae in his pool and it cost him $10,000 to have that repaired. Had he had our system, he could have adjusted his critical loads, run his pool pumps each day, and saved himself that expense. And to make that work and to give the users the power to make those decisions, we again rely on Savant and their powerful systems. So I'd like to bring Tony back and we can talk about our energy modes.
Thanks, Will. So as we go into a little bit more of a live demo, we're going to talk about how this would actually work for your clients in a couple scenarios. So the first thing you're going to see as I go through this demos on this screen, we're going to view what the app mode is. This thinks what the systems mode is. This is an interface that's available within the Savant app. And on the right, we have a virtual representation of a home to give you an idea of what would be going on inside that home at the time. So the first situation we want to talk about is we are going to set up the home in this basic scenario of just a generator and talk about how you can gain a lot of value for your customer, even if that's all you have in your system. So at this point in time, Will's going to simulate a grid outage for me. So what's going to happen is when the grid goes out, we're going to detect that the grid has gone out. At this point in time, the generator is going to get started, it's going to get going, and it's going to stabilize its voltage. At that point, we're going to transfer power back. So at this point, when the power comes back, what we have done, you saw on the screen, we detected while we were in that transfer, this is normally only 2 to 3 seconds on a generator, what we did is we reconfigured that system. So as you can see over here, what's happened is we've now shut off a lot of loads in the home. What that did is that brought us under the threshold of what that generator is capable of supporting. And this is kind of that worst case scenario. This is what that customer built a traditional critical load panel around. So what we're able to do, because we're able to monitor the energy inside that home, what we can do is inform the user of the energy they're using in that moment. And let's say it's in the fall, they don't need to heat or cool their home, they have a lot of excess energy, they've been without power for a couple days, and man, it is now a critical situation that they're able to sit their kids in front of the TV for an hour or two so they can take a break. So our system allows them to dynamically use their power. So of course, the kids' playroom might not have been a critical load on the original layout, but it's not a problem to go ahead and energize that for a couple hours when they know they have power available. So now what we're going to do is see what would look when the inner grid comes back. What's going to happen is we're going to do that same transition. It's going to detect that system, it's going to come back up, and we're going to reestablish the normal state of the home. So just to give you an idea of what you're looking at here, to try to visually explain what's happening in a home here, what we're seeing is we have non-critical and critical loads. For this example, we've chosen things like the refrigerator, some of the lights in the home, the water heater, the HVAC system, and of course the control system as what critical loads in the home might be. We also have some examples of non-critical loads, things like kids' rooms lights, guest room outlets, and other outlets throughout the home that may not be critical for the usage of the home. So as we go through those situations, you're going to see that difference between the critical and non-critical loads. So that kind of gives you an education of when we see these lights change on the wall. This is the classification we've made in the software. So you as an integrator are going to be able to aid your customer and design that system for them right there in the software. And so then you have that baseline of what is a truly critical load versus the loads that the customer has a little more control over. So now I want to talk about what that flow would look like if you have a battery. Because of course, our partner Racepoint Energy is able to help specify solar systems as well as design properly sized battery systems for you across a wide scale of systems. And batteries have a lot of benefits above the generator. So we're going to simulate that same grid outage. The great thing about a battery is, of course, we're still going to probably transfer off onto a critical load panel normally because those also usually don't support the entire system. When this system happens, this same transition that happened before, the home actually stayed in a normal state. And so what you're seeing here is we actually didn't do anything, but you're able to see that the grid has disconnected itself. And so what we're doing now is we're now pulling off the battery. So in this example, you have a whole lot of battery, you're producing some solar, so we're really not limiting what you do. What you just saw happen is our battery decreased to the level that we're saying, hey, you're using energy at a rate that we really think we should throttle it back a little bit and try to balance you on your solar. So we've taken light actions and limited some of these loads, but you see we haven't actually shut them off. What we're indicating here is that we've reduced energy on those loads, but we haven't actually disconnected these loads. As you continue to use energy, if you don't bring yourself back within the range, this is what's going to happen. The same thing that we just saw with the generator, we're going to revert to a truly critical load state because now we've reached a critical level of the battery that we really need to get some charge back in the system and do everything we can to maintain the energy you have. So as the grid comes back up, we're going to detect the grid go out and we're going to detect the transfer happen. And so when the system comes back up, we're going to put the whole home back in normal. At this point in time, we're probably going to start back charging the battery off the grid. We're going to reestablish that battery level just in case you're going to have more energy interruptions. Now, there's some other really neat things we can do with a battery. So one of the neatest things that we can do with a battery is that we can also flip the situation on its head. We're able to allow the customer to choose to go into an off-grid state. So what we're looking at here is what Savant calls island mode. So in this environment, what we're doing is we're leaving your system set up like normal, and what we're going to do is we're going to do everything we can to keep you working off of your batteries and your local solar generation. What this does is it actually now puts the grid in a situation where it is the fail-safe. So in this environment, if you started burning a lot of power, and as we go down, maybe we end up in an environment where we really need to reduce some energy usage. So maybe at this point our battery's gotten to 50%, you're using more than the solar is able to produce at this point. And so we kind of go into that same energy saver mode that we looked at when we were off grid. The big distinction here is if you continue to use above and beyond the production powers of your solar, instead of going into a critical load mode, what's going to happen is the system is going to switch back to grid. So that is now the failure state for this situation is the grid, as opposed to failing to doing a critical load mode. So there's a lot of other neat things you can do if you live in an area of the country that has variable rate pricing. So whether your pricing adjusts by time of day, or if your pricing adjusts based on amount of wattage you've used throughout the day. We can do an energy saver mode that in this money saver mode, what we're doing is informing the customer that we're gonna leave the home in the normal state. And in this state, we're gonna let you do everything you want. What we're gonna do is as you start using more power and getting either to your threshold or at the different time of use, we're actually gonna start pulling battery off of that situation while the grid is there and offsetting the usage in your home to help stabilize your energy bill and keep you out of those high critical load states.